Let's assume we have a uniform distribution of population between 0 and 50. If I just take a sample of size 1, I get, for example, I randomly select an individual and their score is 30. I do it again, I randomly select an individual, their score is 25. Well, I can do this 1,000 times or 5, 6, 10,000 times. And of course, if I'm just randomly selecting one individual at a time, the the distribution of these samples is going to be just 1. Well, that's kind of boring. It's not really taking a mean. I only have an individual. So let's maybe select 5 individuals. Alright, so here we go. 5 individuals, and we take their sample mean. Their sample mean is 28. Alright, I do it again. Here's another 5 individuals. Take their sample mean, and their sample mean is 26. So it's not as likely that I'm going to get a sample mean of 50 or of 0 here, even though I might get an individual score of 0 once. If I'm taking the mean of 5 people, it's going to pile up a little bit more in the middle. So let me do this a bunch of times, and we can see, wow, even with a sample size of 5, it's starting to look a lot more normal. Let's try, I don't know, 35, sample of size 35. I do it once. Obviously the individuals are all over the place, but the sample mean is sort of piles up in the middle. So I take many samples of size 35, and this is what the distribution of the means look like in green down here. That's X bar, or as your book says, it's Y bar. Now notice that the population mean is 25. That's the original population. As we get to take more and more samples, the mean of the means, the mean of X bar, is also 25. The expected value of the means is 25. And you might say, okay, well maybe that's because this is a uniform distribution. So let's do some wacky distribution here. Alright, so it's pretty right skewed, multimodal, etc. So we can see that the mean is 12.009. If I just take samples of size 2, a lot of them are going to be on the left-hand side here, and once in a while it'll go to the right, but it'll probably be right skewed. So if I take, again, a bunch of samples, this is just taking 2 people at a time and seeing the mean of these 2 people. Well, it's still right skewed, even if I take thousands of these samples of size 2. Let's try sample size 5. Alright, 5 people. It'll be slightly more piled up, but if I do this thousands of times, I still have right skewed data. Alright, so how big does my sample size have to be in order for the means to be normally distributed? Well, when I have 35, it looks like when I take my thousands of samples, it looks pretty well normally distributed. Alright, this is an example of the central limit theorem, which says no matter what your initial population distribution, whether it be uniform or right skewed, etc., if I take a big enough sample, as the bigger my sample is, the more likely that my distribution of my sample means, this green part, is going to be normally distributed, and the mean of the means, the mean of the sampling distribution, is the mean of the population.